Okay. So I want to try to understand what we mean by algebra in these ways because it often gets forgotten about. People often make mistakes with collecting terms, and they say things. For example, 4x plus 3 is equal to 7x, or maybe if you subtract 3x, so maybe you do something like this: 7x take away 3x is equal to 4, because you think, well, I've subtracted the 3 and the x, so I just end up with that. But that's not quite right. Now, neither of those two mistakes will happen if we get a clear understanding at what these algebra things mean. So think about the letters as boxes, and I'm actually going to put numbers in this as well. So let's say plus 5, and then we'll say minus 2. So first of all, collecting, we've got x and y's, and then we've got numbers. What we're going to say is that the numbers are like, oh, that got big all of a sudden. Let's try that again. The numbers can be, we can imagine there being these yellow balls. So let's make a few of those. So that would mean 4, that would mean 8, and that would mean 12, and so on, right? So if you saw the number 12, it can be represented by 12 of these little yellow circles. And then these boxes, they have an unknown amount of circles in them. We don't know how many circles are inside these boxes, but we're going to call this box here X, and we're going to call this box here Y. Okay. So now we can get a sort of representation, a diagrammatic representation of what we see here, of what's written down. So we just need to understand the operators, which is the plus and the minus. So plus means just give me that many, and minus means taking it away. So let's go from left to right. Add 4x. So okay, so let's just make them a bit smaller. So that's 1, 2, 3, 4. Okay, now add 3y. Here's the y's. So 1, 2, 3. There's 3y. Okay, now take away 2x. Oh, okay, so we've got to take 1, 2. All right, and then it says add another y. Okay, so there's my y. Then it said add 5 circles. So add 5. There's 5. Now it says take away 2. Okay, so I need to take away 2. All right. So now we can see, just from looking at the picture, that the answer to this problem. Oh, sorry, go on. Well spotted. I've just embarrassed myself on video. I can't do 5 take away 2. So yes, it is obviously 3. So I think maybe did I start with 4 instead of 5 or something? I don't know what I did, but anyway. So that's, I think because I did take away 2, so I think I must have started with 4 instead of 5. Anyway, so you've got, so you end up then, the simplified version of this equation is therefore, where's my pen? Is therefore 2x plus 4y plus 3. Okay? So we can now see why these terms are like. I obviously can't, if I say x plus y, we can't say what it is because we don't know what's inside each box. We're not going to be able to open up. We can't open up any of these boxes. What we can do is investigate. If it turns out that 2y is equal to 6, then we can see therefore there must be 3 in each box. Okay. But at the moment we don't. This is just what we can call an identity because we've got no equals. They've got an equals here just because I've simplified it. So then now we can imagine, well, what are the like terms? Well, we're going to say that's a like term. We've got to include the operator. So as we remember to take it away. And then this this is like, include the operator again. Let's make that blue and that blue. And then these numbers are like terms as well, so we'll make those yellow. Okay, so when you think about it in this way, it's very easy to identify the what terms are like, and so if I said now, well, okay, we've got 4x, and when you rearrange an equation, you're going to take away 2x. We're just going to get 4 boxes and take away 2 boxes. There's still going to be, that's going to be 2x. It's not going to be 2 because we don't know what was in each box, right? That makes sense? Okay, I'll stop the video there and I'll put it